So click go and let's go ahead and complete. We will do on slides up to slide number 6. 7, 8, 9, 10 would be your practice. Now, class, the difference between math and your other subject is, in math, math is not a spectator sport. Meaning, you do not just watch and then you think you know it, right? So you want to watch and then you practice. You want to practice, practice, practice. That's the secret of doing math, of understanding math. You need to practice. And that's why I'm leaving those 4 slides for you to work on. It is self-checking, so you would know whether your answer is right or not. All right, so our objective for today is for you to classify triangles. So you are classifying triangles 2 ways. One, you classify it as to equilateral, isosceles, or scalene. Okay, equilateral, isosceles, or scalene. And then you would want to tell me whether the given triangle is a right triangle or not a right triangle. Okay, so 2 parts when you classify. Okay, so let me stop the pacing right here. I see that everyone has logged in. Please make sure that you are on decimals. Okay, let's move on to slide number 2. Slide number 2. Okay, remember when we mark our triangles or polygons in any case, when you see the same number of tick marks, that means they are equal. So looking at triangle number 1, you have 1 tick mark for this side, 1 tick mark for this side, which means that these 2 sides are equal, okay? And then you have a third side that has 2 tick marks. So this third side here is of different length than the other 2 sides. So for triangle number 1, 2 sides are equal. So what do we call a triangle with 2 sides equal? Is it equilateral, isosceles, or scalene?
Isosceles.
Isosceles, very good. Okay, so it's an isosceles triangle because you have at least 2 congruent sides. Okay, let's look at slide number triangle number 2. So each of these sides has 1 tick mark, which means that the 3 sides are equal. So what do we call a triangle with 3 sides equal?
Equilateral.
Equilateral. Good. And the third one, you see the tick mark, you have 1 tick mark for one side, 2 for the second side, 3 for the third side, which means that all sides have different lengths, right? So what do we call a triangle whose sides are all different? Of course, you only have 3 choices here. It would not be equilateral, it would not be isosceles, it should be scalene. Okay? So these are the 3 classifications that I want you to remember. Isosceles, equilateral, and scalene. Right? So just to recap, equilateral triangles are triangles whose sides are all the same, equal. An isosceles triangle has 2 sides that are equal, and a scalene triangle, no 2 sides are equal to each other. All the sides have different lengths. That is your scalene triangle. Okay? So after classifying it according to equilateral, isosceles, or scalene, you want to tell me whether the triangle is a right triangle or not. Now, how do we know? Here, a triangle is a right triangle if it satisfies the Pythagorean theorem. Again, your Pythagorean theorem is a squared plus b squared is equal to c squared, right? If it satisfies that equation, then you have a right triangle. If not, then you do not have a right triangle. Again, class, please make sure that you are logged in to Desmos, because I see that you are in class, but you are not on Desmos. I don't know what's the problem. All right, so moving on to slide number 4. Okay, we want to determine the length of each side of the triangle. Now, look at the bold bold words in the direction. It says, do not round. We do not want the answers in decimal. We want the answers to be whole numbers, okay, or radicals. What this means is, say you calculated the length, right? The length of the side. And say you got square root of 25. Now, what is the square root of 25? What is the square root of 25 is equal to 5. It's a whole number, okay? Which means that you will have to write in 5, all right? Now, if say you got square root of 20, what is the square root of 20? Can you get square root of 20 exactly? Or do you get a decimal when you get square root of 20? A decimal, right? Now we do not want a decimal. That means 20 is not a perfect square. You cannot get a whole number when you get the square root of 20. So in your answers, you'd want to keep square root of 20. All right? All right, so let's go to this triangle. We are given triangle ABC. All right? So D is the distance. What is the distance from A to B? What is the distance from B to C? What is the distance from A to C? Okay, this is what we're looking for. So since the points are all plotted in the coordinate plane, let's use the Pythagorean theorem. All right? So recall from last Tuesday that if you want to find the distance from A to B, we will have to form a right triangle where AB is your hypotenuse. Okay, so let's do that. AB, so that means we need to form a right triangle here. We draw a horizontal line and a vertical line, and we'll count. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 points. Okay, or 9 units. And then vertically you have 1, 2, 3. So that would be 3 units, right? So you form the right triangle and then you count. Okay, let's calculate the distance from A to B. Now, instead of writing AB squared, I will just get the square root. So I'll put in the square root at the very first step. Okay, then we take the sides. The sides here are 9 and 3. So you have 9 squared plus 3 squared. Okay, 9 squared plus 3 squared. You need to identify, you need to know where we got the 9 and where we got the 3. We got this by counting the number of spaces, okay, on each side. So we get AB equals square root of, what is 9 squared? What is 9 squared?
81.
81, very good. And what is 3 squared? What is 3 squared? 3 times 3 is 9, right? So you have 81 plus 9. Let's add them up together. 81 plus 9 is equal to 90, all right? Now, is 90 a perfect square? Can we get a whole number when we get the square root of 90? If you're not sure, get the calculator and then find the square root of 90. And the square root of 90 gives you a decimal. All right? Now we don't want a decimal, so we are keeping the square root of 90. So 80 here, okay, is equal to the square root. Square root is right here. Square root of 90. All right. Now let's look at BC. Okay, this is your B and your C. So again, using this BC as your hypotenuse, we'll draw our right triangle. Okay, and then we count again. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 units. And then this is 1, 2, 3 units. Okay. So our BC would be equal to the square root of the square of the sides. So the sides are 9 and 3. So you can write 9 squared plus 3 squared or 3 squared plus 9 squared. It doesn't matter the order. Okay? So we get BC equals square root of, notice that they are the same, right? 81 plus 9. So our BC is also equal to the square root of 90. Okay? Square root of 90. Good so far? Okay, now lastly, side AC. Okay, so side AC, we have this right triangle here. Okay, and let's count. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 units. And then horizontal, you have 1, 2, 3, 4, 5, 6. That is 6 units. So our AC would then be equal to the square root of, okay, the sides are 12 and 6, right? So 12 squared plus 6 squared. Okay? What is 12 squared? What is 12 squared?
144.
44. What about 6 squared? 6 times 6 will be 36, right? So our AC is equal to the square root of 144 plus 36 is equal to 180. Okay? Now again, if you try to put this into the calculator, the square root of 180, it would give you a decimal. So we are keeping the radical, the square root. So your AC is equal to the square root of 180. All right? Questions? So this is what we did last Tuesday, right? When we found the distance, the distance. But this time we are keeping the radical if it's not a perfect square. So let's look at this. AB is equal to square root of 90. BC is equal to square root of 90. And then AC is equal to square root of 180. Okay, so what kind of triangle is this? Is it equilateral, isosceles, or scalene? Equilateral, isosceles, or scalene? How many sides are equal? Two sides are equal, right? And therefore, this would be an isosceles triangle. So that's one part. Okay, this is an isosceles triangle. Now we have to test whether this is a right triangle or not a right triangle by using the Pythagorean theorem. Okay, Pythagorean theorem is a squared plus b squared is equal to c squared. Right? Okay. Now first you identify the c. C is the hypotenuse. C is the longest side. So we have these two sides, square root of 90 and square root of 180. Which is the longest side? Is it the square root of 90 or the square root of 180? Which is longer?
180.
180, the square root of 180. So this is your C. All right? And it doesn't matter which of these two are your A and B, as long as we have identified the C, okay? So the other two legs are your A and B. So A is square root of 90. So you got square root of 90 squared. B is also square root of 90. And then C is square root of 180. All right. Now, when you simplify this, the square root and the squared are inverses of each other, right? So what happens is the square root and the squared can just cancel each other out. So the square root cancels out with the square. Square root cancels out with the squared. Square root cancels out with the square. And so what is left here would be 90. This one is 90. And this one is 180. You don't anymore have the square root and the squared. Now 90 plus 90 is equal to 180. And since this checks out, that means the Pythagorean theorem works. And since the Pythagorean theorem works, then we say that this is a right triangle. So this triangle here is isosceles. At the same time, it is a right triangle. And then make sure that you click submit. Okay? So go on ahead and complete your slide number 4. Okay, again, since not everyone is logged in to Desmos, go to your Canvas. All right? Go to your modules. At the very top of your modules are the videos, video lessons. Okay, I will add in week 14 here. We don't do week 13 because week 13 is just a review. So I will add in week 14, meaning the lessons that we did last Tuesday plus this lesson that we are doing today. It will be added on here. So the first part of your module are the video lessons that you can go back to. The second part of your module is the list collection of the assignments and quizzes. Now I put them together so that if you are missing any homework assignment or any quiz, this is where you would go. All right? You don't have to scroll through all the modules, all the weeks at the bottom, right? You'll just find them here, any work that you are missing. Of course, week 14 is not here yet because we are still in week 14. Next week, when we are on week 15, the week 14 assignments will be in this particular part of the module. Okay? And then after the collection of the assignments and homework, the third part will be the lessons. And this is arranged, the lessons at the bottom would be, okay, this is MP3. Okay. MP4 starts with week 12. So the latest lesson is at the top. So week 12 is at the bottom, week 13, and then week 14, this is the latest. Okay, this is the week we're on. So the week we're on is right after the list of assignments and quizzes. We are on day 2 of week 14. Okay, day 2 of week 14, you can see the dates. You click on this assignment, all right, and then click on your period, and it will bring you over to the Desmos. All right, so hopefully you follow that. Okay, let's move on to slide number 5. Are we all okay with 4? Okay, slide number 5. Let me just look at this. All right, so slide number 5. This is in table form, okay? So we are given triangle DEF, and we will identify whether the triangle is equilateral, isosceles, or scalene. All right, so let's start with DE. DE is right here. And DE is a vertical line, right? So if it's a vertical line, straight vertical or straight horizontal, you don't need to draw a triangle. All you need to do is to count. So how many spaces or how many units from D to E? Let's count. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 units. Okay, so let's type in 10 here. And you get that smiley face. All right, next, EF. So for EF, this is your EF. So we will draw our horizontal and vertical, okay, to form that right triangle. And then we count. So this would be 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units. And then this is 1, 2, 3, 4, 5, 6. That's 6 units. All right. So EF would then be equal to the square root of, so the sides are 8 and 6. So you have 8 squared plus 6 squared. Okay, that's correct. So we get EF equals square root of 8 squared is 64 and 6 squared is 36, right? And 64 plus 36 is equal to 100. Now, can we get the square root of 100? What is the square root of 100? 10. Yeah. So your EF is equal to 10. So since it's a whole number, we'll use the 10. We'll not use the square root of 100. Okay? We'll use the 10. So your EF is equal to 10 units. Okay? All right. Now we have one side remaining, DF. This is our DF. So again, let's draw our right triangle. And then let's count. So that would be 1, 2, 3, 4. And this is 1, 2, 3, 4, 5, 6, 7, 8. Right? Okay. So DF would be equal to the square root of, again, we have to square the sides. So 4 squared plus 8 squared, or 8 squared plus 4 squared. Okay. So 4 squared is 16. And 8 squared is 64. Okay. Therefore, our DF would be equal to square root of 16 plus 64 is 80. Okay. And we know that 80 is not a perfect square. When you get the square root of 80, you get a decimal. So we don't want a decimal. That means we are keeping the square root of 80. Okay? Square root of 80. All right, so let's look at the sides. DE is 10, EF is 10, and DF is square root of 80. What kind of a triangle is this? Isosceles triangle. So DE is 10, EF is 10, and this is square root of 80. So you have an isosceles triangle here. Okay, next question. Is it a right triangle or not a right triangle? Okay, this is not a right triangle. Very good. Because, why? Okay, again, if you apply the Pythagorean theorem, you need to identify the longest side, right? Now, in a right triangle, there is only one longest side. So what's your longest side here? Which is longer, the 10 or the square root of 80? The 10, because 10 is basically square root of 100. So it's like you are comparing square root of 100 and square root of 80, right? And 100 is greater. How many 10s do we have? We have 2 of them. Right? And as I was saying, you cannot have 2 longest sides. You cannot have 2 longest sides. So this one would be a non-right triangle. Now, if you wish, you can try the Pythagorean theorem. So you have a squared plus b squared equals c squared. We'll take one of the longest sides as your C. So say your C here is this side, okay, which is 10. So the other 2 sides would be your A and B. So you have 10 squared plus square root of 80 squared equals C is 10 equals 10 squared. So 10 squared is 100. Square root of 80 squared, again, the square root and the squared will cancel out. So that gives you 80. 10 squared again is 100, right? So if you add 100 plus 80, you get 180. And we know that 180 is not equal to 100. So the Pythagorean theorem is not satisfied. Therefore, this is not a right triangle. You get it, or is there any question? Okay, so let's move on to slide number 6. By the way, class, this is not triangle JKL. This should be triangle LMN.
Can you go back, Miss Anne, please?
Sure.
Okay, thank you.
All right. So again, as I was saying, this should be triangle LMN. Now, class, the difference between this question, this problem, and the previous ones, in problems 4 and 5, the triangle is already on the coordinate plane, right? It's already drawn for you. The points are plotted. Here, you're just given the coordinates of the point, and it's up to you to plot the points. If you want to use the Pythagorean theorem, you need to plot the points. So you saw the worksheet earlier for the quiz, so you can plot the points right there. Okay? If you want to use the Pythagorean theorem. If you want to use the distance formula, you don't need to plot the points. Okay? So let's try just to review. Let's try using the distance formula for LM. Let's try using the distance formula. Okay. So L, coordinates of L is -2, 3. And the coordinates of M is 1, -4. Just for this one class. So -2, 3, and M4. Okay. Now recall that the first coordinate is your X, the second is Y. So this is XY, this is XY. So the X values are -2 and 1. The Y values are 3 and -4. Okay. And for your distance formula. So the distance formula, okay, remember this, you set it up, right? You have 2 sets of parentheses and then subtraction in between. So this first set is for your X coordinates. And then the second set would be for your Y coordinates. All right? Now, on the first set of parentheses, we'll put in our X. So the X values are -2 and 1. Again, it doesn't matter what the order is. So -2 and 1. Okay? For the second parenthesis, we put in the Y value. So the Y coordinates are 3 and -4. So 3 and -4. Again, the order does not matter. All right. Now, what is -2 minus 1? Read again. -2 minus 1. If you are not sure, class, okay, -2 minus 1 is equal to -3. Okay, so that's equal to -3. Again, we put it in parentheses because it's negative. What about 3 minus -4? So 3 minus -4 will give us 7. So 3 minus negative 4 is 7. So that's 7 squared. So negative 3 squared is negative 3 times negative 3. It would always be positive. And 7 squared is 49. So the distance from L to M is square root of 58. Okay, 9 plus 49 is equal to 58. All right? Okay, so that's your LM. Square root of 58. All right, then you get that smiley face again. So we just do this. I just did it for one side, so you don't forget how does the distance formula works. Okay, you can always plot the points and do the Pythagorean theorem. Can I scroll up? Are we good with this? Again, class, whenever you see this notation here, the box on this box on decimals where you have this, you can write your work on a piece of paper and then upload it here. Take a picture and then upload it here, okay? Because sometimes it's hard to write on the computer. All right. Now, I don't want to take for granted that everybody knows how to plot points. So if you are still confused on how to plot points on the coordinate plane, let's try to plot the following. Because if you do not know how to plot the points and if the problem is given this way, it's hard to get the correct distance between the points. All right, so first point is negative 2, 3. Remember, the first number is your x, the second number is your y. In other words, the first number tells you the horizontal displacement, and the second number tells you the vertical displacement, right? So the first number here is negative 2, positive 3. So from the origin, it's negative 2, so we move left. 1, 2, 2 units. And then positive 3 means we go up 3. 1, 2, 3. So this is our point L. Okay? Then second, we have M. M is 1, negative 4. So positive 1, we go right. And then negative 4, we go 4 units down. 1, 2, 3, 4. So this is your point M. And then lastly, your point N is negative 4, negative 2. So 1, 2, 3, 4, 4 units left. Negative 2 means 2 units down. So that would be your point N. Okay, and then let's connect these 3 points to form the triangle. All right. So we found LM by using the distance formula, but let's verify using the Pythagorean theorem. So LM is this side. We form that right triangle again. All right, and then we count. So that's 1, 2, 3 units. This is 1, 2, 3, 4, 5, 6, 7 units. All right, so your LM, using the Pythagorean theorem this time, would be equal to the square root of, what are the sides? The sides are 3 and 7. So you have 3 squared plus 7 squared. Okay. Now 3 squared is 3 times 3. That is equal to 9. Thank you for those who are answering my questions, responding through the chat. I cannot quite read it, so yeah. And then 7 squared would be 49. And 9 plus 49 will give us 58, right? Now, 58 is not a perfect square. When you get the square root of 58, you get a decimal. Okay, which means that we have to keep the square root of 58. Same thing, we got this. Okay, square root of 58. Now, let's look at MN. Now, some of you would be able to do this on your own, so go on ahead. But for those who still need for me to work this out, you can listen here. The rest of you that already knows how to do this, go on ahead and complete this slide. So for MN, this is our MN. Okay, again, we form our right triangle, and then we will count. So that's 1, 2 units. And then this is 1, 2, 3, 4, 5 units. Okay, so the sides are 2 and 5. So our MN would be equal to the square root of, the sides are 2 and 5, so 2 squared plus 5 squared. 2 squared is 4, that's 2 times 2. 5 squared is 25. It's 5 times 5, not 5 times 2. Okay, 5 times 5. So MN, therefore, 4 plus 25 will give you 29, right? So our MN is square root of 29. Good? All right. And then lastly, we have side LN. So side LN okay. So this is 2 units, 1, 2, and this is 1, 2, 3, 4, 5 units. Okay? So Ln would be equal to the square root of, the sides are 5 and 2. So 5 squared plus 2 squared. Evaluating this, we get square root of 5 squared is 25 and 2 squared is 4. So again, you get square root of 29. All right. So if you practice on the lesson from last Tuesday, this would have been, this should be just as easy, okay? So let's look at the sides. So one side LM is square root of 58. So this is LM. That side is equal to square root of 58. Okay? MN, this is our MN, is equal to square root of 29. And then LN is also square root of 29. So one side is square root of 58. The other two sides are both square root of 29. Now, I don't know what happened, why these are all the same. So this one is an isosceles triangle because you have two sides that are equal. Okay? Now again, to test whether this is a right triangle or not, we use the Pythagorean theorem. A squared plus b squared equals c squared. Now which one is our c? Which one is our c? Is it the square root of 29 or the square root of 58? 58, because that's the longest. So C is equal to square root of 58, right? So square root of 58 squared. Other two legs are square root of 29 plus squared. So that's your A squared. And then your B squared is square root of 29 squared. Now it just so happened, class, this is not the rule. It just so happened that in these examples, you have an isosceles triangle, which is at the same time a right triangle, okay? So 29 plus 29 is 58. And since it's satisfied, then we say that this is a right triangle. All right? Okay, so it's 1:15. Again, if you have